In Chapter 11, we're going to discuss techniques for managing path segments to be followed. In this video, we're going to review the architecture and show a demonstration. And then in following lectures, we're going to discuss various techniques for doing so. We're going to discuss switching with half planes. We're going to discuss the utilization of fillets to smooth our paths. And we're also going to discuss the use of Dubin's paths. So let's go ahead and get started. If you recall, in Chapter 10, we created a path following control capability. And that path following control required a path definition. This path definition was either a straight line or a circular arc. Well, in Chapter 11, we're going to be producing that path definition for the path follower to follow. And we're going to produce that using a series of waypoints. So a series of waypoints is depicted here. It's just a series of positions defined to be followed. So in this case, we define this capital W as just our series of waypoints, where each waypoint is just a vector or a position in R3, and it's solely the positions. Later when we talk about Dubin's paths, we will actually include orientation as well. But the idea is we have this path defined to follow, and this path consists of a series of different points in a sequence. And so we need to decide when we're going to be following, or when we're going to be executing which portion of the path. So for example, we'll start off, if our UAV is right here, we'd start off trying to follow this line segment. Now, once we get to a certain point, we have to decide how are we going to switch to executing the line segment between W2 and W3. And we have a few options. One, we could just go straight through W2 and then switch and start executing our line following between W2 and W3. Or two, we can we can smooth that out using circular arcs, execute the line segment W1 to W2 for a while, switch to a transition arc, execute the next one for a bit. Or third, we're going to be talking about Dubin's paths, where we can directly go between any two oriented waypoints. And so we can add an orientation to each waypoint and just define circular arcs and straight lines to get to each individual waypoint. So to show that, we're going to bring up the Python code, and we can see each one of these techniques in action. So let's go ahead and switch over there. And the first one we're going to do is just what we'll call a straight line. And we'll have a video on that. But the key point is, if I can get it over there, we have our series of waypoints. We have our aircraft following it. And it's just executing this line. So this line that it's executing is shown in purple. It executes that purple line until it arrives at the waypoint, and then it switches. There we go. We switched again. So you see that we have a significant amount of overshoot as we're traveling along that line. One of the benefits to that is that we do go through each individual waypoint. We just don't have as a great a knowledge for exactly how we're going to execute that transition. Okay, so let's switch that up, and we'll do the fillet-based technique. So here's our fillet. So instead of just executing those straight lines, what we'll do is we'll smooth the path out. So just as before, we're executing that straight line, but now before we get to that waypoint, we're just going to go on a circular arc of the minimum radius that the aircraft is able to execute. So as we go through there, we don't execute all the way, or we don't follow the path all the way to the waypoint. We're going to cut it off and smooth that path using circular arcs. Okay, so that's the fillet-based technique. And now let's look at the final one we'll go over in terms of Dubin's paths. Now Dubin's paths are great. They allow us to have the shortest path between two oriented waypoints, but for following a series of waypoints, they end up producing, this path actually isn't too bad. They produce kind of wonky paths to follow. So in this case, we actually get to the desired waypoint, which was right there. We follow a circular arc, and then we'll get to the next desired waypoint, which was, I think, right there. So, or actually maybe it was right there. So then we can define a path using circular arcs and straight lines that'll get exactly through the waypoints. The problem with Dubins is if we define our orientation a little bit wrong, then we'll have kind of wonky paths, and we'll show that. But the key here is that we can use circular arcs and straight lines to either do straight lines, fillets, or Dubins transitions. And then we'll have lectures going into details on each one of those.